Hello everyone, this is our today's topic, STP, RSTP, and MSTP configuration of Wi-Tek Cloud L2 management switch. First, please let me introduce what is STP. STP protocol is a data link layer protocol agreed in IEEE 802.1d, which is used to solve the problem of network loops guaranteed in the construction of redundant links at the core layer of network by transferring bridge protocol data units. By using the HTA spanning tree algorithm to elect the root bridge, root port, and design port, the network is finally formed into a tree-structured network, in which the root port and the design port are in the forwarding state. Other ports are disabled. If the network topology changes, the spanning tree topology will be recalculated. The existence of the spanning tree protocol not only solves problems, the network robustness requirements of the core layer network that needs redundant links, but also solve the broadcast storm caused by the physical loop formed by the redundant links. And this page shows STP port rollers. First is root bridge. For an STP network, there is only one root bridge in the entire network. When selecting a root bridge, a switching device with high performance and a high network level is generally selected as the root bridge. The root bridge will change dynamically according to the change of network topology. During STP configuration, it is recommended to manually configure the root bridge and backup root bridge. Please configure the core switching device as the root bridge to ensure the stability of the STP layer 2 network. And next is root port. The port with the lowest path cost on the root bridge. The root port is responsible for forwarding data to the root bridge. The selection criteria for these ports are based on the path cost among all STP-enabled ports on a device. The one with the lowest root path cost is the root port. Obviously, there is only one root port on device running the STP protocol, and there is no root port on the root bridge. And the last is specific ports. Specify the port to forward the configuration message to the local device. Specify the port to forward the configuration message to the local network segment. In a complex network, due to need to redundant backup network planners usually tend to deploy multiple physical links between devices, one of which is used as the active link, and the other links are used as backups. In this way, a ring network is bound to be formed. If a loop occurs on the network, broadcast storms and MAC entails may be destroyed. After planning the network planner can deploy the STP protocol in the network to prevent loops. When a loop occurs in the network, STP achieves the purpose of breaking the loop by blocking a certain port. There is a loop in the current network. Switch A, B, C, and D all run the STP protocol. They exchange information with each other to discover loops in the network and selectively block certain ports. Finally, the ring network structure is pure to be loop-free. The tree-shaped network structure avoids the continuous circulation of messages in the ring network and avoids the reduction of processing capacity caused by replay the reception of the same message. And this page, I'll tell you what's our configuration ideas. And later, we are going to follow these ideas to do the configuration. First, configure the spanning tree protocol of the devices in the ring network to work in STP mode. Turn on the spanning tree protocol mode of switch A, B, C, and D. Select STP mode. Second, configure the root bridge and backup root bridge device. Switch A is configured as the root bridge switch. Switch D is configured as a backup bridge switch. Third, configure the path cost value of the ports to block the ports. Configure ports 24 and 26 on the D switch as blocking ports. Fourth, enable STP to break loops. The port connected to the PC does not need to participate in the STP calculation, so it is set as the edge port. Configure port 1 of switch B and switch C as an edge port. Okay, let's keep going. The first step is to enable STP function on switch A. Switch A as the bridge. We will change its priority to 0. 0 is highest priority. The second step is to enable STP on switch B and keep the priority at the default value. Then select an interface on switch B and go to the idiot screen. Select Enable the interface as an edge port. Then set switch C to enable STP function, keep the default priority. Then select an interface on switch C and go to the idiot screen. Select Enable the interface as an edge port. Don't forget click Apply button. Switch D is used as the backup root bridge, so we need to change the priority to 4096. In addition to root bridge device, 4096 is the second highest priority. Then select ports 24 and 26 on switch D as blocking ports. Click Idiot here to change the path cost of the interface to 2 million. Our configuration all about the STP is completed. Next, we will configure the RSTP. And now, please let me introduce what is RSTP. The Rapid Spanning Tree Protocol is used to eliminate the physical loop of the data link layer in the local area network, and its core is Rapid Spanning Tree algorithm. RSTP is an improvement from STP. In addition to the functions of avoiding loops and dynamically manning redundant links, like the traditional STP protocol, RSTP also greatly shortens the topology convergence time. Now is RSTP port rollers. In a complex network, network planners generally tend to deploy multiple physical links between devices due to the need for redundant backup. one of which is used as the active link, and the other links are used as backups. In this way, a ring network will inevitably be formed. If there is a loop in the network, broadcast storms and MAC entiles may be destroyed. After network planners has planned the network, RSTP can be deployed on the network to prevent loops. When there is a loop in the network, RSTP achieves the purpose of breaking the loop by blocking a certain port. As shown in the figure, there is a loop in the current network. Switch A, B, C, and D all run RSTP. They discover loops in the network by exchanging information with each other and selectively block certain ports. Finally, the ring network structure turns it into a loop-free tree network structure, thereby preventing messages from continuously circulating in the ring network and avoiding the reduction in processing capacity of device due to repeated reception of the same message. And this page is our configuration ideas. Later, we will follow these ideas to do the configuration. Let's have a look. First, configure the spanning tree protocol of the ring network device to work in RSTP mode. Turn on the spanning tree protocol mode of switch A, B, C, and D. Select RSTP mode. Second, configure the root bridge and backup root bridge device. Configure switch A as the root bridge switch. Switch D is configured as a backup bridge switch. Third, configure the path cost value of the port to be blocked port. Configure ports 24 and 26 on switch D as blockade ports. Ports enable RSTP to break the loop. The port connected to the PC does not need to participate in STP calculation, so it is set as an H port. Configure port 1 of switch B and C as H ports. Okay, let's do the configuration. The first step is to enable RSTP function. On switch A as the bridge, we will change its priority to 0. The second step is to enable RSTP on switch B and keep the priority at the default value. Then select an interface on switch B and go to the EDO screen. Select Enable the interface as an H port. What's more, set switch C to enable RSTP and keep the default priority. Then select an interface on switch C and go to the EDO screen. Select Enable the interface as an H port. Switch D is used as the standby root bridge, so we need to change the priority to 4096 when we enable RSTP. Then select ports 24 and 26 on switch D as blocking ports. Click Idiots button here to change the path cost of interface to 2 million. And at last is our MSTP. MSTP is a multiple spanning tree protocol that allows multiple spanning trees to run in a switching environment. Each spanning tree is called an instance. It also provides multiple redundant paths for data forwarding and realize load balancing of VLAN data during data forwarding. MSTP is also compatible with STP and RSTP. This page is MSTP port rollers. In a complex network, due to need for redundant backup, network planners generally tend to deploy multiple physical links between devices, one of which is used as active link, and the others are used as backup links. In this way, loops will inevitably be formed. If loops exist on the network, broadcast storms and MAC entails may be destroyed. Therefore, MSTP protocol can be deployed in the network to prevent loops. MSTP can block redundant links in the layer 2 network. As shown in the figure, switch A, B, C, and D all run MSTP. MSTP introduce multiple instances to implement traffic load balancing between VLAN 2 to VLAN 10 and VLAN 11 to VLAN 20. MSTP can set a VLAN mapping table to associate VLANs with spanning tree instance. This is our configuration ideas. Later, we will follow these configuration ideas to do the configuration. Let's have a look. First, configure the spanning tree protocol mode of switch A, B, C, and D. Select MSTP mode and configuration the region name as default. Second, configure the layer 2 forwarding function of the device in the ring network. Section A. Create VLANs 2 to 5 on switch A, B, C, and D. Section B. Add ports in the access loop on the switching device to VLAN 2 to 5 and set the port mode to trunk mode. Section C. Configure switch B's port 1 to join VLAN 2 and set the port mode to access mode. Configure switch C's port 1 to join VLAN 5 and set the port mode to access mode. Third step, configuring basic functions of MSTP, Section A. Configure switch A, B, C, and D to create instance MSTI1 and instance MSTI2. Section B. In domain RG1, configure the root bridge and backup root bridge of MSTI1 and MSTI2. Switch A is the root bridge of MSTI1 and the backup root bridge of MSTI2. Switch D is the root bridge of MSTI2 and the backup root bridge of MSTI1. Section C. Configure the passcodes of the ports to be blocked in MSTI1 and MSTI2 to be greater than the default value. Okay, let's do the configuration. The first step is to enable MSTP on switch A and customize a region name. Then create VLANs 2 to 5 on switch A. Step 3. Add interface to corresponding VLANs. In this case, set interface ports 24 to 26 to trunk mode. Step 4. Add ports 24 to 26 interface to VLANs 2 to 5 and set them to target mode. The next step is to create MSTP instance 1 and map VLAN 2 to VLAN 3 to MSTP instance 1. Since switch A serves as the root bridge in MSTI instance 1, the priority in MSTI 1 is set to 0. And you need to know 0 is highest priority. What's more, the next step, we will create MSTP instance 2 and map VLAN 4 to VLAN 5 to MSTP instance 2, since switch A serves as the backup root bridge in MSTP instance 2. The priority in MSTI2 is set to 4096. Step 7. Configure ports 24 to 25 as blockade ports in MSTP instance 2, while the path cost is set to 200 million, the biggest value. The next step is to configure switch B, enable MSTP, and customize region name. Please make sure name keep it set as the switch A. Okay. Then create VLANs 2 to 5 on switch B. Step 3. Add interface on switch B to corresponding VLAN. In this case, set interface ports 24 to 26 to trunk mode. Step 4. Add ports 24 to 26 interface to VLANs 2 to 5. Set them to target mode. Step 5. Add the port 1 interface to the corresponding VLAN. That is, set the port 1 interface to the access mode. Step 6. Add interface 1 to VLAN 2 and select the untarget mode. The 7th step is to create MSTP instance 1 and map VLAN 2 to VLAN 3 to MSTP instance 1. Set the priority in MSTP 1 to 32768. The next step is to create MSTP instance 2, map VLAN 4 to VLAN 5 to MSTP instance 2, and set the priority in MSTI2 to 32768, same as the MSTI1. And step 9, select interface 1 and click Edit. Then select Enable for H ports and apply. Then we set switch C and set it to MSTP protocol. Then set the same region name as the switch A. Then create VLANs 2 to 5 on switch C. Step 3. Add interface on switch C to the corresponding VLAN. In this case, set interface port 25 and 26 to trunk mode. Add ports 25 and 26 interface to VLANs 2 to 5. Set them to target mode. Step 5. Add a port 1 interface to the corresponding VLAN. That is, set port 1 interface to access mode. Step 6. Add interface 1 to VLAN 2 and select the untarget mode. The 7th step is to create MSTP instance 1 and map VLAN 2 to VLAN 3 to MSTP instance 1. Set the priority in MSTI1 to 32768, third highest priority. The 8th step is to create MSTP instance 2, map VLAN 4 to VLAN 5 to MSTP instance 2, and set the priority in MSTI2 to 32768, same as the MSTI1. Step 9. Select interface 1 and click Edit. Then select Enable for H ports and apply. And last, we set switch D and set it to MSTP protocol. Then set the same region name as the switch A. Then create VLANs 2 to 5 on switch D. Step 3. Add interface to corresponding VLANs. In this case, set interface ports 24 to 26 to trunk mode. Add ports 24 to 26 interface to VLANs 2 to 5 and set them to target mode. The fifth step is to create MSTP instance 1 and map VLAN 2 to VLAN 3 to MSTP instance 1 since the switch D so as backup bridge in MSTP instance 1. The priority in MSTL1 is set to 4096. The fifth step is to create MSTP instance 2 and map VLAN 4 to VLAN 5. MSTP instance 2 since the switch D serves as the root bridge in MSTP instance 2. The priority in MSTL2 is set to 0. Step 7. Configure ports 24 to 25 as blockade ports in MSTP instance 2, while the path cost is set to 200 million, the biggest value. And if you follow me to do all the configuration, you have handled all the configuration. Okay, that's all about today. Thanks for your listening. See you next time.